Welcome to the next session. I'd like to introduce Michael Plöd with his talk, Systems Thinking by Combining Team Topologies with Context Maps.
All right. So, welcome everyone to this talk, and quick disclaimer on it. You can join this talk. I will add some interactive elements to that talk, so pull out your smartphones. Usually speakers say, put the smartphones away and focus on me. No, put them out and join this talk. You can react to this talk with emojis if you want, and send some feedback. But I will also have some interactive elements in this talk where I will ask you some questions and get some feedback from you on some ideas. Because I'm very honest, on this topic, I'm currently presenting where I am opinion-wise right now. So maybe I may be right with some aspects, or maybe I will do my surname justice. So what is that? The Germans will understand that. If you replace the P of my surname by a B, it translates to stupid. So, so maybe, yeah. There may not be the smartest things in this talk from my side, but it's my current way of thinking, my current way of looking at things. I also don't know how this AHA slides thing is going to work out for us. And I see it's obviously not working right there. Hello? Okay. If it's not working, I may fall back to Keynote. So maybe you wanna, if you look at your smartphones, I will ask you to rate your knowledge on these things. Yeah, and if you do that and it's loading, then maybe, just maybe, I do have an internet connection. Let me reload. Something went wrong. Fancy new tech is always nice.
Can you check whether it's connected? Because with the other talk we had problems with the internet here.
It's connected. On Marriott guest.
Otherwise, with the other one,
okay.
we use the personal hotspot. So if you
okay.
have a hotspot, use that one.
Let me switch to my smartphone. If it doesn't work, I will have to switch to Keynote and we will have to ditch the interactive stuff. Oh. Yeah. Thank you, AHA Slides. Appreciate it. Not. So, something went wrong. Please reload your browser. Yeah. Let me reload things. So, yeah, maybe, now, maybe, give it a shot. If it's failing on the next thing, I will fall back to the standard presentation because I don't want you to hang out on me waiting for technical stuff. So, but I would like to know what your knowledge is about bounded context, context maps, team topologies, and so on, because this will have an impact on certain slides, where I'm going to be faster or not so fast in my talk. So what I see there roughly, that quite a few folks know bounded context. Some of you know a little bit about context maps, some about team topologies. So I will have to show all of the slides. Okay, now at some conferences, I've done a workshop with Eduardo on sociotechnical evolution and architecture, and one very similar slide that we showed is, so we want to maximize the value exchange with customers in a continuous fashion. Or how our managers say, we want to be fast, we want to have autonomous teams, microservices, fast, and maybe we don't want to change a thing in our current behavior, but that rarely works. And this is something that we want to address in the Agile community. The domain-driven design community talks about these things. But how do we do that? And a good idea was in the Accelerate book by Nicole, Jess, and Jean. And they said a loosely coupled software architecture and organizational structure to match are a key predictor for continuous delivery performance and the ability to scale the organization and increase the delivery performance in a linear fashion. Now, basically what that says, and if we take in some inspiration from some of our favorite books here, we would say that we want to model our software along the business domain. No surprise here for folks at a DDD conference. And yeah, we want to align our software to a certain degree with teams. That's something that the Team Topologies folks, Matthew and Manuel, heavily talk about. Now, those are the basic ideas here in this area. And so Eduardo also has a very nice quote in his blog post. And we're obviously talking about sociotechnical architectures here. That sociotechnical architecture is about taking a holistic co-design approach to technical and organizational systems, given the inherent impact they have on each other. Or, in another quote, a more simpler one by Michael Nygaard. Team assignments are the first draft of the architecture, what Michael Nygaard says. So if you have a database team, a back-end team, and a front-end team, and you tell them, build me a mortgage loan application, they will build you a back-end, a database, and a front-end. If you tell them, build the new Netflix, they will build a front-end, a back-end, and a database, obviously. Now, this is something that we want to address to a certain degree. And this statement by Michael mentions two kinds of alignments. Team boundaries, on the one hand, team assignments, and software boundaries. And he says that there is a certain implicit alignment that becomes explicit. Now, another perspective on that comes from Robert Frost, who said, good fences make good neighbors. Let me add another perspective to that. What Daniel H. Pink says, what motivates people? Autonomy, mastery, and purpose. And so in the end, when we want to become faster, when we want to have independent teams, we sort of need good boundaries in which teams can achieve this autonomy, mastery, and purpose. And the idea for that is heavily pitched in the DDD space is obviously the bounded context. And I like this definition for a bounded context quite a bit. A bounded context is a boundary for a model expressed in a consistent language and tailored around a specific purpose. So what do we want to achieve with this? We want to have a boundary within which a team or a group of people can master and learn a certain domain complexity, where they can conduct experiments and where they can learn, where they have the time to explore things in their area, to find out what does work, what doesn't work, to identify new ideas, and where they are able to deliver high-value software. Now, if we take a look at that, I think we can have a checkmark and mastery and purpose. So if we have this boundary very well, and I'm not talking about how you find those boundaries, there is no time for that in this talk, and that's also not the topic, but we talked about, so there is a certain purpose, and we want to master the complexity of that purpose, but I think what very often gets mixed up a little bit is this autonomy part, because I think autonomy can be a consequence, yeah, but it's not a trait to a bounded context. And I think this is where we need to take on a broader look. And for instance, what Eckhoff, who gets probably quoted like crazy at this conference, said, to manage a system effectively, you might focus on interactions of the parts rather than their behavior taken separately. So what do I mean with that? I think if we take this quote and take a look at that from an autonomy perspective, isn't autonomy about the interactions or a reduction of interactions or maybe even a lack of interactions between teams? Yeah, because the more interactions we have, the more coordination we need, the more collaboration we need between those teams. And I think our goal here is to reduce this part. And how do we work there? So an idea is that we want to add a third level of alignment, like the domain boundaries with the idea of the bounded context. And this is where the Team Topologies folks come into play. So a quote, a very heavily quoted sentence from the Team Topologies book says, as an architect, you should be thinking, which team interaction modes are appropriate for these two teams? What kind of communication do we need between these two parts of the system, between these two teams? And I think this quote reads very nicely. I think you can even tweet it and whatever. It sounds smart, it sounds good. But there is one detail that I like quite a bit of here. And that's the interactions part here. Yeah, so how do these teams interact with each other? What are the dynamics between the teams or between those boundaries that we have defined for those teams? And so since quite a few folks have said, I have a rough knowledge about team topologies, I will explain some of those topologies, and their interaction modes. So basically, team topologies defines 4 fundamental types of teams. So on the one hand, we have the complicated subsystem team, the enabling team, the platform team, and the stream-aligned team. Now, the stream-aligned team is, I think, the team where most of the team topologies world puts a lot of emphasis and focus on. So we want to make sure that this team gains a high degree of autonomy, that they can move fast in their area of business. And they are usually aligned to certain capabilities. Very often, so the team topologies folks talk about fracture planes, and so that's a choice for finding boundaries. And a very popular one that is heavily pitched in the book is the bounded context, especially for the stream-aligned teams. And I would say especially bounded contexts who are part of a core subdomain. Yeah, so this is where you really want to excel and shine. Now, hello, to your slide. Ah, no? Okay, so let's continue. The complicated subsystem team. That's another team type that is responsible for building and maintaining a part that is extremely complex, yeah? Where you need specialized knowledge, which is hard to find on the market. But please, please don't fall into the trap saying, oh, in our shop, everything is complex. We're just dealing with complexity. And so this can end up in a bunch of really interesting lame excuses. Yeah? So in a perfect world, you wouldn't want to have complex subsystem teams. If you manage that, then you're managing your complexity really well. Now, the platform team, on the other hand, goes ahead and tries to reduce the cognitive load of the stream-aligned teams by providing them with a platform that these stream-aligned teams can use. So very popular platforms are continuous delivery, CI/CD platforms, runtime platforms on the cloud, but also think about business platforms. Like you find that very often in generic subdomains, like sending and receiving letters. Yeah, a capability that is widely used by a bunch of teams, and there is really no sense in reinventing the wheel again and again and again and again and again. Yeah, there's no sense in that. So don't just think about technical platforms there, but also business platforms. And so you find that, for instance, in the financial services area very often, in the insurance area, you can think about platforms about like basic insurance functionality, basic financial services functionality. And I recently read a quote that says, when the platform team is amazed at what the stream-aligned teams do with their platform, what products they build based on that platform, the platform team is probably doing a pretty good job. I like that comparison quite a bit. And then we also have the enabling teams, and they are there to teach the other teams, yeah, in terms of methodologies, technologies, new stuff. Eduardo had a talk about architectures as enabling teams, a brilliant idea, I think. Yeah? No one wants to have ivory tower architects who are just bouncing back and forth PowerPoint slides and UML diagrams and telling do this, do this, do this. If you're not doing that, we'll escalate. No one wants that. But enabling other teams to do proper architectural work may be a good idea. And now in team topologies, we also have a bunch of team interaction modes. Collaboration is high bandwidth communication between the teams. So they spend a lot of time in meetings. Well, no one wants that. Yeah? So you want to have collaboration, not very often, rarely, maybe for a limited amount of time. Especially you want to avoid long-term collaboration between stream-aligned teams. The more collaboration they need, the slower they will get, because they have to coordinate their efforts all the time. We have X as a service as another relationship. So very often seen on complicated subsystem teams, or especially platform teams that offer services to other teams. But please mind, those should be self-service capable services. So think about the Google Maps API. Yeah, Google Maps as a platform for navigation, point of interests, and whatever. They offer an API. You can sign up to their API. You get an API key. You enter your credit card. You're good to go. Yeah, so that's what is meant there. And we have the facilitating. That's obviously for those enabling teams, where they enable. But I've also seen scenarios where we were releasing stream-aligned teams at a customer out of a complex subsystem. Yeah, so we were extracting smaller parts out of a monolith, and in order to teach those teams, in order to help them, we had a temporary facilitation relationship between certain stream-aligned teams, or between the complex subsystem team and the stream-aligned teams. That can happen, yeah, but make sure that this happens only over a limited amount of times, that the other teams are then able to run free again, to move forward. And in team topologies, you can go ahead and visualize these relationships, how they, oh, wait a minute, that's the wrong one, how they relate to each other. So there's those fancy graphics and images there. You also find, I would say, Miro templates for that, and so on. So a very important thing is cognitive load, especially for stream-aligned teams in team topologies. And one thing that the team topologies folks heavily pitch to you is that, again, it's not loading. So, hello. Okay, screw this. I'm sorry, but I don't want to waste too much time playing around with AHA slides loading too slow. So, okay, this works better. So what they say is that the bounded context is a team-first boundary. Yeah, so that you should look at bounded context from a team perspective. Now, if we summarize the ideas that team topologies look at, we can say we have classifications for teams, we have collaborations, we have services and interfaces, maybe on an X as a service relationship, we have enabling teams, or the task of enabling is something that team topologies cover, and team topologies take a team-first boundary. Usually, if AHA slide would work really well, I would ask you the question, and you can now reflect that a little bit in your heads. Now, where do you see the shortcomings of that model? Where do you see the downsides of that model? Or where do you think that this model ends here? I mean, there's really interesting stuff, and I mean no disrespect towards the team topologies community or anyone involved there, but I think when we take a look at that from a systems perspective, where we want to understand a system as a whole, yeah, and the dynamics of a system as a whole, I think we need to dig a little bit deeper than this. We need another level of digging deeper to really thoroughly understand the system. So I think what I suggest to most of my customers, start off with the team topology stuff, because that's stuff that is really nicely understandable, and you can communicate that very well to various stakeholders in an organization. But at the time being, I would like to dig a bit deeper into those ideas. And I think this is where context maps from strategic domain-driven design come into play. Now, there is a direct connection right now. So that comes from the fracture planes in Team Topologies, where they heavily have the idea of the bounded context being an interesting driver for a team boundary. Now, Team Topologies have a team-first perspective, as I said it. The context maps have a bounded context-first perspective. So they, first of all, take a look at bounded context, their relationship to other bounded contexts, and then take a look at teams as well. And however, there are also a few things in there that have a connection point towards teams. And it's the dependencies between teams. So we don't talk about relationships, we talk about dependencies in the context map. So for instance, mutually dependency is, again, very similar, where we have two teams collaborating heavily together, talking a lot to each other, having a high communication bandwidth. Those teams usually go ahead and have to synchronize their efforts in terms of testing, releasing, and so on. And this mutual dependency means so you're team A, I am team B. If you do something, and if you change something, I have to do something as well. And if I change something, and if I do something, there's a very high likelihood that you need to do something as well. So obviously, we have to talk. I would love talking to you, but if we talk about team independence, maybe we don't want to do that too much there. Now, the other one is free. Yeah, so there is no direct relationship between the teams. They don't need to coordinate with each other. And we have upstream-downstream relationships. So let's say, Javiera, you change something, and I need to change something as well. But when I change something, you don't have to do anything. Yeah, so one of us is upstream, the other one is downstream. Yeah, so the upstream team is in a very powerful position, because they couldn't care less about the other team. Yeah? Eric Evans has a nice quote in the Blue Book where he says something like that the downstream team is helpless at the mercy of the upstream team, or something like that. Typically Eric Evans sentence. Now, in that area, the context map digs deeper and describes relationships between bounded contexts and teams in roughly 9 patterns. I would say those are the most popular ones. I'm not going to run you over all of these 9 patterns here. We don't have the time for that. I'll just mention a few of them. But if you want to dig into that, there is a nice website on GitHub called DDD-crew. And there is a context mapping project there where we have published a cheat sheet that describes all of those patterns. There is a starter kit for Miro where you can download a Miro board backup and get up and running with the visualizations of context maps. So if you want to dig deeper, you may want to check this out. Now, I will just pick a few of those, which I need later on when I dig back into the team topology stuff. I'm sorry. Now, the first pattern is the open host service, which is very easy to understand. It's basically, you could consider that to be a public API. So one bounded context offers functionality over an API that is tailored to various consumers. So it's not an API for you, an API for you, and an API for you. No, I'm offering an API for all of you in a take it or leave it manner. Yeah, so we would visualize that as OHS, and usually the team that is providing an open host service is in an upstream position. They are in a very powerful position. There are exceptions, which very often include very powerful regulators, especially in the financial services industry. I've seen that quite a few times, where the regulator tells the bank, so you need to provide me with an open host service for all of our apps or applications, and we have the control, so then the open host service would switch to the downstream. But if you're getting started with that, and you take a guess that the open host service is upstream, you have a very high likelihood that you're right. Now, each open host service offers usually a model to others. So if you go to a credit agency, if you go to the Google Maps API, they will offer you a model. And you can think, oh, what am I doing with the model? So one chance could be that you build an anti-corruption layer. So we take the model of the open host service and transform that into our own model. Like this. Boom. Scoring has its own model. So there is a model-to-model transformation happening there. The other extreme of that would be the conformist, where we say, this mapping is complicated. We don't need that. We like that model, that external one, really well. So we pull that in. So we're lazy. We just take the external model. And this is obviously a higher degree of coupling, because you couple into the heart of your other bounded context. So the domain model of the other bounded context resembles the external one very much. Now, quite a few of you may think, oh, conformists are a stupid idea. No, they are not. They are fast, they are cheap, they are easy. At a cost. And it's a trade-off, what you want to do. I've built quite a few conformists where I would say I would build them right again. That was a good idea of doing that, especially when you're in generic domains or something like that. Of course, you wouldn't want to conform on an external system in a core domain. That would not be the best idea around, I think. We also have the shared kernel, where we say, okay, we are tightly coupled, based on a shared artifact, like a shared database, a very high degree of coupling, and make sure, when you look at shared kernels, how the team interaction modes are, and how the relationship between the teams are. If you have two teams from two external vendors that are competing at your company, and they have a shared kernel, you run a high risk that this thing will turn out to be really toxic. I've seen teams sabotaging each other over shared kernels. You don't want that. But in certain situations, that may be a viable solution. It depends, as always. You don't want those teams to be in an enemy ship. You want them to be in a partnership, where they work very well together. And partnership obviously goes hand in hand with a mutual dependency again. And finally, we have the customer supplier as the last example, where a downstream team is allowed to make some requests against an upstream team. So that's customer supplier relationship. So context maps enable us to visualize different perspectives. So on the one hand, we can take a look at a first level of team relationships. We can take a look at an API level. We can take a look at how models are being propagated. We can take a look at a deeper level of team relationships. And those context map patterns, they address different aspects of relationships between bounded contexts and the teams. Now, if we now move into the combination of team topologies and context maps, we start off with looking at team topologies, and then let's see what the context maps bring to the table. I think they have a shared intersection, like teams, collaboration, services, interfaces. But context maps add something. They take a look at domain models, something that team topologies doesn't talk about at all. They take a look at governance processes. Think about customer-supplier relationships, stuff like that. About team dependencies and not relationships. About organizational solutions. So for instance, there is a pattern called separate ways, with which you can model organizational solutions where you're ditching a technical integration between two teams and two systems. On the one hand, as a design decision, which is very interesting when you talk about minimum viable products, and you say, okay, at the beginning, we don't need a perfect integration. We go for a manual process there. Good enough. Or when you visualize existing system landscapes. So for instance, in call center software, I've seen really interesting things where call center agents were working with 4 applications in parallel, and then the integration was done by keyboard shortcuts, Control-C, Control-V, copy-paste. You want to see that. Something that Team Topologies doesn't mention at all. And context maps start at context boundaries first. And now I think, yes, you can combine both ideas to get an interesting deep dive into those topics. So the first question we could raise, so we have those stream-aligned teams, right? Now, there is one word in stream-aligned teams called aligned. Now, let's check how aligned are our stream-aligned teams. Are they really well aligned along a bounded context, along a certain bounded context? So, in this case, we have a stream-aligned teams around two purposes. Well, I would say this alignment is okayish. You can live with that. Yeah? But this team is not tailored to a specific purpose. And what I would heavily take a look at here is if the cognitive load of that team is still suitable for them to be able to do their work. The more important their domain is, the more critical this becomes. So if you have, let's say, a team in a core domain which is heavily overloaded with work from various bounded contexts, and maybe they are not as cohesive as they should be, you may want to readjust things. So you can use that as a check. And I mean, if we go with bounded context as a team first boundary, maybe that's a better suited thing. However, this is not, I would say, this is not a strict pattern here. It's always an it depends discussion. So you need to take a look, and I would discuss this heavily from a cognitive load perspective. If one or two bounded contexts, or even three bounded contexts for a stream-aligned team are okay. I can imagine every scenario. I just want to make you aware to think about these things. Now, another thing that we could do is when we take a look at complicated subsystem teams. So how complicated is the responsibility of this team, and how tangled is it? I mean, complicated stuff may also, or complex stuff may also arise from a tangled mess that you sometimes have. And this is basically not the core idea of the complicated subsystem team in Team Topologies. Team Topologies, they basically say that this requires a specialist knowledge that's hard to find on the market. I interpret it, and I may be wrong there, from a perspective where you say, okay, so this is domain knowledge that is very, very specialized. So no one wants me to implement something for autonomous driving of a car. That car would drive everywhere, but not along a road. So it would probably end up in the Mall of Berlin somewhere. And now, very often, I also see complicated subsystem teams sitting on top of big ball of mud monoliths. Or let me not call it big ball of mud legacy software, because I actually like well-structured monoliths quite a bit. Now, how is that structured? So you can take a deep dive into that by seeing, okay, they are responsible for those bounded contexts, and those are the context map patterns. For instance, here we see 3 bounded contexts with a shared kernel, some conformist, some anti-corruption layer, and an open host service which provides functionality to the outside. So you can also check this and maybe think, maybe we can change some of those patterns. We can refactor some things that we don't need the complicated subsystem team anymore. So maybe we can transform that within half a year or a year with some reteaming efforts to stream-aligned teams. So you can play through various scenarios and you can visualize them. And I always say this stuff are mainly, or I mainly use them as communication tools, as a means to communicate with various stakeholders in an organization. So you can play through various scenarios, you can compare models, run them through some change scenarios and stuff like that. Now the learning here is, with context maps, we can go ahead and dig into the boundaries of a single team first, and see if the software to domain alignment suits the team type that we have. So you can do this deep dive on the other hand. But there is another opportunity, and that lies in the relationships between those teams. So for instance, we have an X as a service team relationship between a complicated subsystem team and a streamlined team. Now, how does this relationship look like in detail? I mean, I can ramp up an X as a service relationship with a lot of loose coupling by using, for instance, anti-corruption layers or published languages and stuff like that. But I could also see a scenario where we have a shiny, nice X as a service relationship between two teams that looks really nice and everyone's happy with it. But under the hood, we're using conformists or maybe even a shared kernel for that relationship. Well, whereas with the shared kernel, I would be very skeptical if I would still call this as an X as a service relationship. But think about conformists. Yeah? So a higher degree of coupling between these two. Now, you can go ahead and visualize that. So you add another level to this relationship where you say, okay, we have this bounded context here of the complicated subsystem team provides a service in the form of an open host service. They are the upstream, the other team is the downstream, and they use an anti-corruption layer. So if I would see something like that, I would be happy. I would say, yeah, okay, there is a high chance that we have a certain degree of loose coupling here. Let me show you some other examples. Let's talk about a platform team to a streamlined team. Now we have an X as a service relationship on the upper one, but with a customer-supplier relationship. I would say on a one-to-one relationship, that may be okay. But if you have a platform team that serves many clients and offers an open host service for doing that X as a service relationship, and now let's say they have 10 customers against the service. 2 of them are in a customer-supplier relationship. Maybe they are doing that in a constructive fashion. That they say, hey, we have this nice feature idea. We would need this. And it would be really nice if. So then everything is okay. Because that's actually what the platform team is supposed to do. They are supposed to run the platform as an internal product. But now imagine a scenario where the platform team wants to move forward with their platform, expand things, change things. Now you have a team that says, stop, you can't do that. We're out of budget, we're out of time, and by the way, the risk for us is too high. Now they become something like something that I like to call, that's Michael Plöd slang here, a vetoing customer. So not a constructive customer who says, oh, I would like to have that, but they mainly just say no. And if you do that, we'll escalate. And I go playing golf with the manager all the time. And you will run into trouble. I would say then you are in a problem. So I usually advise against having customer-supplier relationships against open host services. So again, here, it depends on a Team Topologies level. Things look neat, they look nice. But how is reality? And I think this is where we can dig a little bit deeper with the context maps as well. Now, the example below, yeah, we may have an X as a service relationship, but in a totally manual fashion, yeah, by going separate ways. Now, another perspective. Let's talk about collaboration from Team Topologies. So we have a complicated subsystem team, which is in hopefully temporary collaboration with a streamlined team. Can happen, yeah? Especially if you pull out some of the complexity of the complicated subsystem teams into a new team in an IT transformation or something like that. But how does this collaboration really look like? Let me show you something really ugly here. So we could say, okay, we have a mutual dependency between those two teams, based on a shared kernel, and the two teams have a partnership. I would try to get rid of this as fast as possible, because in the midterm, if this stays mid to long term, the stream-aligned team will never be able to fulfill the expectations that you have against a stream-aligned team. A team that is able to move fast, a team that is able to work in a certain degree, yeah, of a high autonomy, yeah, with regards to other teams. So as a transition step, that may be okay. But you can also say, okay, this is a warning sign here. Yeah? So we want to get rid of that. And of course, you may think, okay, that just makes things worse by digging deep. We don't want to have collaboration over a mid to long term anyways between the teams. Fair enough. Yeah, absolutely. That's what you really don't want to have. But yeah, this is something that you want to get rid of as fast as possible. So what does that tell us? Yes, let me summarize things up a little bit. So if we take a look at that from a systems thinking perspective, which aims to understand a system as a whole, yeah, combining both approaches together, I think makes quite a bit of sense, especially when you really want to dig deep into those dependencies and into those dynamics. I think what I always recommend my customers, start with Team Topologies. I would say that's a really good starting point, and this is something that you can communicate very well across various stakeholders. But when the questions on those relationships get more complicated, or if you want to have more detailed answer, you can take that as a starting point and then dig deep into those relationships. And I think the patterns in the context mapping section of the DDD book are really good ideas. Yeah? And I think the combination of both allows us to really understand the system as a whole, something we want to do, and the dynamics of a system. Yeah? So I would say dynamics may include communication, but also model propagation. Yeah? So how a domain model moves from one bounded context to another is also a form of dynamics that are happening there. Yeah? But also governance, yeah? Who is able to raise requests against whom is a form of dynamics. Who talks to each other, who doesn't talk to each other, who vetoes, who doesn't veto, and so. And this is something that we want to understand. We want to understand the dynamic nature of the system. Because saying, oh, we want autonomous teams is easy. But what does that mean? How autonomous, how independent do we want those teams actually to be? So the team topologies also say we're optimizing for flow. Yeah? So, and I think if you really want to get a flow, you should also take a look, for instance, at stuff like model propagation and stuff like that, so that we really can get into a flow. And now, summarizing that with the value exchange with the customer, we can say that in the middle part here, yeah, is the question, what enables the maximum value exchange? The other part is, how are we doing it? Who is doing this? The first part, I think, is something we can address with collaborative modeling. Didn't talk about that, event storming. How are we doing it? Or bounded contexts. Who is doing this? I think there is an interesting take if we take a look at team topologies in a combination with context maps. So I'm 5 minutes ahead. Usually you would have spent those 5 minutes in some questions and writing on AHA slides. I'm really sorry for the technical glitches, but the network was unstable, as it always is. Stupid me. But thank you very much. I will be at the InnoQ booth today and tomorrow. So if you have any feedback, or you can say, Michael, those were a bunch of utterly stupid ideas, or you can also go ahead and tell me why. Or you can also go ahead and say, hey, I have additional ideas, or did you take a look at that from that perspective? I would also be very happy to get your feedback, to learn from you. Yeah, we're all learning here. And thank you very much for listening. Enjoy the rest of the conference.